This example says the absolute value of x minus 7 plus 3x is equal to negative 3. To solve this, subtract 3x, so I can isolate the absolute value. That gives me x minus 7 in absolute value is equal to minus 3 minus 3x. Now your first instinct might be to say that, okay, we're setting an absolute value equal to a negative number, therefore this is impossible. But notice, if I had a big negative number for x, this equation could actually become positive on the right side. So in that case, the equation is solvable. So we can't quit just yet. We need to keep going forward. So how can you solve this equation? Well, remember, if I had something like x minus 2 is equal to 3, what I could do is just say this whole thing is equal to the positive version of the number or the negative version of that number. Well, remember, minus 3 minus 3x at the end of the day is just a number. So what I can do is set it equal to the positive version of this or the negative version of that. In other words, I'm going to set up two equations. Let's say x minus 7 is equal to the positive version of that, which means I just keep it as it is. Or I can make the whole thing negative, and that'll give me a new equation. So I have x minus 7 is equal to minus 3 minus 3x. And these are two separate equations that we can use to solve for x, and then check the solutions at the end. So I'm just going to solve this first one at the top really quickly, and I'll do the next one. To solve this, add 7 to both sides. So that's x is equal to minus 3 plus 7 is 4, and then you have minus 3x, and then just simply add 3x to both sides. And if I do that, I'll have 4x is equal to 4, which means that x is simply just equal to 1, because you divide by 4 on both sides. So let's save this solution so we can check it at the end. I'm just going to erase all of this here, and I'm going to write x is equal to 1 at the side here, so we save that solution. Now I need to set x equals 7 to the negative version of whatever this is. So it's equal to negative 3 minus 3x. If I distribute the negative sign, that becomes 3 plus 3x. To solve for x, subtract 3 from both sides. Then I'll have x minus 10 is equal to 3x. So just subtract x from both sides now. And if I do that, I'll have minus 10 is equal to 2x. Just divide by 2 on both sides now. Oops. And if I do that, I'll have minus 5 is equal to x. So now we have two solutions. We have x equals 1 and x equals negative 5. But what if both of these solutions aren't actually correct? Why don't we try checking our answers and see if both these are correct or only one of these is correct? So first, let's check x equals 1. If I plug that into our initial equation, let me just erase all this so you can see it. That's 1 minus 7 plus 3 times 1 is just 3 is equal to negative 3. Now let's see if this is a true statement. 1 minus 7 is negative 6 plus 3 is equal to negative 3. Well, the absolute value of negative 6 is just positive 6. And if you add that to 3, that is not equal to negative 3 because 6 plus 3 equals 9. Therefore, this does not work out. That's not true, which means that x equals 1 is actually a fake solution. So now we only have x equal to negative 5 remaining. Let's check if this is a valid solution to our equation. So let's set this up. I'll have minus 5 minus 7 in absolute value plus 3 times minus 5. And we want to verify that this is equal to negative 3. Minus 5 minus 7 is minus 12 in absolute value. And then 3 times 5 is just, or 3 times negative 5 is negative 15. And this thing's supposed to be equal to negative 3. Minus 12 in absolute value just becomes positive 12. And then 12 minus 15 is just negative 3. So notice we got negative 3 equals negative 3. That makes sense. That's a true statement. Therefore, x equals minus 5 is a true answer. So notice how we got two answers from this absolute value, but only one of them was true. So this is why it's important to check your answers at the end when solving absolute value equations.